Hi, welcome to solving radical equations, which is 5D for us. Alright, I am going to follow the steps step by step. I'm going to do even problems. I'm going to start with number 2. So first we need to isolate the radical. To isolate the radical, we need to move all of our terms outside of the radical. Everything that's outside of it, we need to move away from the radical. So subtract 3. And we still have a negative on the outside, and that negative is attached to the radical by a multiplication. Think of it as -1, divide by -1, divide by -1. We get a fourth root of m equals positive 3. Now the radical is isolated. Now we're going to raise each side to the power of the index. The index is the root. It's a fourth root. So we're going to raise it to the fourth power and 3 to the fourth power. And that's going to be m equals 81. And solving the remainder equation, there isn't one, so that's it. You don't have to check. You only have to check for extraneous solutions when we have a quadratic. And at no point did we have a quadratic like an m squared. Number 4, so we need to isolate the radical, so subtract 10. -7. Now radical's isolated, so we square. We have 6m minus 5. -7 squared is 49. Now we solve the remaining. What's underneath the remaining equation? So we have 54 divided by 6. We get to m equals 9. Number 6. Now, for number 6, we have to remember that a cube root of x is the same thing as x to the 1/3. You have your 1 goes to the numerator, 3 denominator. To undo an exponent of 1/3, we are going to raise everything to the multiply by the reciprocal, so an exponent of 3 over 1, which is 3. I jumped ahead though. I forgot that this 11's here. We gotta move that first. My bad. Got excited about raising to a power. So now we need to raise to a power, multiply by the reciprocal, which is 3. So -4 to the 3rd. And looking at our exponents, the reason why this works, multiply by the reciprocal, 1 times 3 is 3, and 3 times 1 in the denominator is 3. And then -4 to the 3rd is -64. 3 to the 3rd is 1. 1, anything to the first power is just, that's itself. So 7p minus 1 to the first power is 7p minus 1. So that eliminated our exponent of 1/3. And now we solve the remaining equation. 7p equals -63, divide by 7, we get p equals -9. Didn't have a quadratic anywhere in the problem, so we don't have to check for extraneous solutions. All right, next one, we have a multiplication and an addition. We have to do a reverse order of operations, so I'm going to subtract first. I'm going to divide. Now that the radical is isolated, we square. It's a square root, so we square. That equals 25. And then we solve the remaining equation. Divide by -3. 2 negatives divide to a positive. Again, we didn't have a quadratic anywhere in the problem. This wasn't x squared at all. So, no, don't have to check. Number 10. So for when you have multiple radicals in the problem, multiple radicals, all you're looking to do is simplify or isolate one of the radicals. Well, they both happen to be isolated, so I'm going to raise it to the fourth power. Raise the other side of the fourth power. Fourth root and fourth power simplify. And then we need to add. And we can add to the other side. So we get 30 equals 3d. Divide by 3, divide by 3. We get d equals 10. No quadratic in the problem, so we can leave it there. All right, number 12. So we have two radicals, two cube roots. We just gotta make sure one's isolated. The left side is isolated, so I can raise it to the third power. Raise the right side to the third power. And on the left side, we get 14 minus 10n. On the right side, what's happening here is you're distributing, really you're multiplying your exponents. So it's negative 2 to the first power. So it's going to be whoa, sorry about that. It's going to be negative 2 to the third power. And then we have a cubing a cube root. We'll cancel that out. So it's times n. You don't need the little times there. Well, let's simplify what we have. Negative 2 to the third is negative 8. So that becomes negative 8n. Get our like terms together. Put my n's on the right side, leaving me with my constant 14 on the left, equals 2n, divide by 2, and our n is going to equal 7. Nowhere in here do we have n squared at all, so no quadratics. We can move on. All right, number 14. Here, isolating the radical, so I got to subtract 7a. We get 12 minus a equals a, and now it's isolated, so we're squaring. Left of 12 minus a equals a squared. Add a, subtract 12. We get 0 equals a squared plus a minus 12. Now we have a quadratic, so now we have to look at factoring. So my a term is 1. When my a term is 1, I can think about what two numbers multiply to negative 12. So like 6, negative 6 and 2, negative 4 and 3. Switch those negatives, negative 12 and 1. Switch them around. We have to think what multiply to 12 that adds up to the b, 1. And that is going to be positive 4 and negative 3. Those are our second terms of our factors. Now set each factor equal to 0. And solve those little equations, one-step equations. So we have a equals negative 4 and a equals 3. Now, we're not quite done yet. We had a quadratic, so we need to check for extraneous. What you're going to check with is the very beginning equation. We have 12 minus, and I'm going to start with negative 4, substitute negative 4 in, plus 7 times negative 4 equals 8 times negative 4. So I'm going to simplify the left side of the equation, so that's negative 12 minus a negative is opposite of a negative is a positive. Minus 28 on the outside equals negative 32. So 16 is 4 minus 28, and equals negative 32. Now it does, negative 4 minus 28 is negative 24, and that does not equal negative 32. So that tells me that negative 4 is extraneous. It's not an actual solution. Let's check the next one. I'm going to check 3. So square root of 12 minus 3 plus 7 times 3 equals 8 times 3. 12 minus 3 is 9, plus 21 equals 24. Square root of 9 is 3, plus 21 equals 24. 24 equals 24? Sure does. Great. A equals 3 is my solution. All right, number 16. So left side is isolated, so we square, square. Left side, wonderful. 2v plus 3 comes down. The right side, I have a binomial squared, so I'm going to have to multiply it out. V plus 2 times v plus 2, multiplying v plus 2 times v plus 2, it's v squared plus 2v plus 2v plus 4. So v times v times 2, 2 times v, and 2 times 2. On the left side, we have 2v plus 3. I now see a quadratic, the v squared, so I'm going to move all the terms to one side. Gather in my like terms. This might look a little strange, but I'm going to do it to save a little space. We have 2v plus 2v plus another 2v, that is 6v total. And then we have 4 minus 3 is 1. Did I? something's not right. What did I do? What did I do? What did I do? Square minus. I feel like I did something wrong. Oh, I see it. I should be subtracting 2v. Okay. Whew. In a time crunch. So we have 2v plus 2v is 4v minus 2v is 2v. Looking at factors, we have v plus 1, so it's what two numbers multiplied as c that add up to b. And because we have the a is 1, it's v plus 1 and v plus 1. It's 1 and 1. Set them both equal to 0. Well, they end up being the exact same. Both factors equal to 0. They're the same exact solution. Let's check this. So with the original equation, oh no, 2 times negative 1 plus 3 equals negative 1 plus 2. And we have negative 2 plus 3 equals 1. 1 equals 1, square root of 1 is 1, 1 equals 1, great. So that tells me that's a solution. Alright, let's move on to 18. 18, we have squaring this quadratic, or squaring. So we have square root of x minus 1 times the square root of x minus 1, and let's multiply that out. Square root of x times the square root of x to the square root of x squared, which is going to end up being x. We have a negative square root of x, another negative square root of x, and a plus 1. We have square root of x squared is x. We have like terms, so that's negative 2 square root of x plus 1. Get our like terms together. I don't have any quadratics, so gotta get my like terms together. And we actually have a radical left, so we're gonna get that isolated again. Minus x, subtract 1, and we are left with 8 equals negative 2 square root of x divided by negative 2. We get the square root of x equals negative 4. We square it, and x is going to equal 16. Now let's check it. I guess we don't have to check it. We didn't use a quadratic. So that is your answer. All right.